Hola, hola, hola. ¿Ahí se me escucha bien? ¿Sí? Cuando me digan. Bien, muy buenos días a todos.
Good morning, everyone. First of all, allow me to introduce me. I'm Sandra Reyes. I'm part of Luckner staff, and on this occasion, I will be the Master of Ceremonies during this event, both for the remote and in-person participants during this week. I will now introduce Oscar Robles, who is Executive Director of LACNIC, and Laura Kaplan, Development and Cooperation Manager of LACNIC, who will be providing guidance for the new participants in order to make the most of every single day of the event. I will introduce Oscar Robles. He now has the floor.
Buenos días. Buenos días a todos, a los que están presentes.
Good morning, everyone, those of you who are present and those of you online. It's a real pleasure to meet our community again and to get together again with all the people who want this interaction with LACNIC. I'm going to give you an introduction, explaining what LACNIC is and why we organize this party, this event, where we meet the community for learning and providing information. I have a few slides. First of all, let me tell you what LACNIC is. Let me move forward in the slides. I would just want you to see that we are one of the 5 regional registries of numeric registries, together with ARIM for North America, RIPE for Europe, APNIC for Asia Pacific, and AFRONIC for Africa. We are the 5 numeric resources. We speak of IPv4, IPv6, and ASN's resources, the autonomous number system. So this is, our function is very specific, that is to manage a very specific registry. However, we recognize that our function is not just to administer this small database. To do that, we require the participation of our community, and for our community to really get involved in our processes, we put together all this infrastructure to keep this learning going, to build liaisons, not just intellectual and professional, but also human. So that is why it's so important for us that once we can work in person, we devote time and effort so that we can meet again. So let me give you some information about LACNIC. Today, LACNIC has about 12,000 organizations, many of which are internet access providers. Many of them are companies with a range of services, not just for access. There are universities, government offices, and an endless number of legal entities. So together with the NIRs, the National IP registries of Mexico and Brazil, we have about 12,000 members. Our region has 33 territories in Latin America and the Caribbean. And it's an international association, it's non-profit, it was created in Uruguay, and this year we are celebrating our 20th anniversary, and hopefully we'll be able to celebrate it together. What topics are discussed this week, or what topics are we going to deal with? Well, first of all, this is a space for encounter. It's not just a formality that needs to be met, but there are many elements, many formal elements of protocol that we need to address, but to a great extent, it's a space for encounter. You're going to find that here we have instances for learning. The public policy forum is a space where we construct not only we define the rules for the LACNIC services, and it's through those policies that we establish the rules for managing the services of LACNIC. So we provide information and presentations all week long. Today we have tutorials, workshops, and welcome for the people, for the newcomers. And now we will tell you how to interact and how to establish our links, and of course, how to learn. So not only, we don't do this alone, but we do it jointly with a number of organizations in the region. You'll see that today we have the LAC Peering Forum organized by LAC IX, the traffic in the Caribbean that exist with us in the House of the Internet in Montevideo, where there are 10 to 11 organizations that work with the Internet in the region. So together with some of those organizations, such as LAC IX or LAC ISP, that is the organization of ISPs in Latin America and the Caribbean, we aim at promoting these events to establish synergies, collaborations, and I hope that you may have a very productive session. Please come closer to those spaces where you are interested for learning, networking, the social spaces, and I hope that this week will be highly productive. So now Laura will tell you some aspects in further detail. She's going to speak of the trusted leaders, the code of ethics that you have to attend, the code of conduct that you have to abide by. So now I'll give her the floor to Laura. Good morning. I'm Laura Kaplan. I'm the Development and Cooperation Area Manager, and as Oscar said, I'll tell you about some aspects. I can't go any further. There are some aspects as to how you can make the most of the event. There's an app that you can download to your phones or to your computers, and what the app will enable you to do is it has a number of functionalities. Not only do you have the agenda, but you can also see the participants that are sharing in the event, and not just in person, but also for the participants that we have a remote. So we are going to see the complete list. We have two functions that were designed to improve the networking opportunities. The first is MAT, and it's there. It has a red arrow with an icon as if it were a magnifier and a magnifying glass. And the other one is one-to-one, that is to hold meetings, one-to-one meetings. And when you download the app, it's called Eventos LACNIC, you'll see that it's LACNIC 37. And if you want to use the one-to-one, for instance, what you have to do is to configure the availability to hold meetings. And there you will see all your timetables, so people will be able to book meetings and see when you are available, and you'll be able to do it with other people. You'll also be able to keep a record of all the past meetings, so that after the event you may have a log of everybody you talked to. It's important for our online participants to know that these meetings were prepared also online to be streamed. You have video call possibilities where you can talk with other people that are participating online. And we have a function that's called a feature that's called Max, so that when I load my profile, I can set the topics that I'm interested in to discuss with other people. and that I can contribute with, that I'm a person that I can discuss and offer. So when we click on that, if people are looking for us, or if we are looking for people on a certain topic, we know who to exchange views with. And one of the last things is that the listing of the participants is organized twofold. Not only can you see it from the side of the participants, but also the list of companies. On the other hand, leaving this plenary room, you'll have the Luckner booth, and there you will find what we built. There is a space with consultations, with individualized interviews with people of Luckner, and you can book specific times for certain topics, but spontaneously you can approach the booth and talk to whoever is there at the time, and that person will give you advice about the different topics. The specific topics that we have prepared are how to deploy IPv6 and configure RPKI, invoicing and membership, internet user probes, IPv4, IPv6 transfers, participation issues such as the tech women, IT women, and our development of software and CCERT and others. And here, let me tell you that Luckner and the Luckner community has a code of conduct. When you registered at the event, you may have seen that in addition to registering, you are asked to declare that you agree with Luckner's code of conduct. And it's important to bear that in mind, because that is what makes these very productive meetings to be done with the greatest respect among participants. So this is a very short website. I invite you to come in and read it if you haven't yet before registering. And essentially, please consider that what we aim at with the code of conduct is that we want to promote the conduct that we expect from all the members. That is to promote respect and consensus of all the meetings that have to do with acting in the interest of what's better for the community. And there are 3 conducts that are unacceptable, that are inadequate behaviors, harassment, and discrimination.
Algo suceda.
In the case that something may happen during the event and somebody wants to seek for support, we have the trusted leaders that are not the people that participate in a complaint for a specific event, but these are people that are here at the event, and some of them belong to the staff and some belong to the Luckner community, and they have a support role. What does this mean? That some situations that you may have had and that you'd like to discuss with a trusted leader, just to let the trusted leader know, or to receive advice as to how to file a complaint in case you need it. They are here. Let me give you the names. You have the pictures. I'm going to tell you Adriana Rivero, Ernesto Majo, and Kevin Swift of Luckner staff, Leah Solis, Max Larson, and Ricardo Patara as part of the community, and Paula Mansi. You may have seen her. She's our support trusted leaders. In their badges, they have a tag that says trusted leader, referente de confianza in Spanish, and their pictures are on the website just in case you want to check that. And finally, let me give you some housekeeping information. Well, we are at a convention center. We are all accommodated in the same hotel, and we come to the convention center every day together. There are buses waiting for you at the door of the hotel, and when you leave the convention center to take you back and forth. In the event website, you'll find the time tables. The buses are going to be available every 15 minutes to come to convention centers, and when we leave, and then they're going to rotate, going back and forth to the hotel. And then we'll have a lunch here. It's the square, the expansion square is where we'll have lunch. There are some. Yeah, you'll see it outside to your right. And then we'll have the welcome cocktail once we are done with our work. The welcome cocktail and the social event are two important events because they give you a chance to know people, to talk, and to be able to talk about things in a more relaxed space. So I invite you to join us this evening with all your colleagues, and you'll get to know the LACNIC staff and the board and members of other organizations. So the welcome cocktail is today at 6 p.m. at the Plaza Leta en Expansión. And then let me tell you that we have a networking area that is in the second floor. It's a room that is open round the clock if you want to hold meetings or to go with your computers. You can have access to them. And finally, what I said about the social event, that will be on Wednesday. 7:45, the buses will leave from the hotel, not from here. So we have to go from the convention center back to the hotel, and it is from there that we'll go. It's called Mulato Cabaret, and it's going to be a feast where we can chill out and enjoy of each other's company. That's all. And now I'll stay here for a minute to hear if there are any questions, and if in the Zoom chat the people that are online have any questions that they'd like to ask. Well, so if you can't think of anything today, all week long we are going to be at the LACNIC booth. We are going to be there or at the registry, or you can look for the staff badges, and you can approach us and ask anything you may have. So thank you. Welcome again. Make the most of this week.
Bien, muchas gracias, Laura. Hola, hola. Hola, hola, ahora sí. Muchas gracias, Laura. Muchas gracias, Oscar. Quiero darles la bienvenida nuevamente para quienes recién ingresan a
Thank you once again to all those who are joining us. Thank you for participating and for wishing to be part of this event. Let me just add on to what Laura was saying. In addition to the networking room in person and the app, we also have a Discord channel so that you can take the opportunity of that space. We're going to start today with two tutorials. The first tutorial will be towards increased security in interconnection and peering. This will be held throughout the entire day until 1800 today, 2300 UTC for those who are following us remotely. And parallel to that, we'll have another tutorial on operation of IPv6 only networks and data centers. This will be held in the Melendez 1.1 at the same time. Let me also mention that the two tutorials will be recorded and later on published in the website of the event, so you will be able to take advantage of the two tutorials. Let me also tell you that during this tutorial that we'll be having in this room, we'll have simultaneous interpretation in 3 languages, Spanish, English, and Portuguese. For those who are following us by Zoom, those will be able to access through the link at the bottom of the Zoom screen. Now let us go over to the tutorial towards increased security in interconnection and peering. These will be analyzing the fundamentals, the business relationships, and the technical aspects of the traffic exchange, peering, among other topics. In this tutorial, we'll discuss, and this will be done in person and remotely. I now invite Guillermo Sicileo, leader of research and development in infrastructure of the Internet at LACNIC, Erika Vega, engineering manager in MC&H Networks, Santiago Aggio, a specialized electronics expert in data networks and computing networks in scientific and research areas, Massimo Candela, senior software engineer at Global IP Network Division of NTT Limited, Silvia Chavez, network coordinator of the Corporación Universitaria para el Desarrollo de Internet in Mexico, and Nicolas Antoniello, regional manager for technical participation at ICANN, who will be joining us remotely. So let me welcome the instructors, and without further ado, I'll give the floor to Guillermo, who will begin with the tutorial.
¿Se escucha? Bueno. Bueno, buenos días.
So good morning, everyone. Let me now start with the peering tutorial. Let me tell you briefly how we have organized this full-day tutorial. Silvia is now joining me, and Santiago, Erika, and myself. Well, we have Massimo Candela, and joining us by Zoom, you have Nicolas Antonello, who could not come in person. Now, the idea of this tutorial is to start with a theoretical presentation on the topics of interconnection and peering and how to improve routing security. Following the break, Massimo Candela, who's also part of this tutorial, will be presenting a more practical way of monitoring RPKI and monitoring the BGP announcements. Massimo will speak in English, but in addition to having the simultaneous interpretation, he can understand the questions, and I will be seated next to him in case he needs support. So that will be in the morning. This afternoon, we will have a lab, a practice session of all the things that we are speaking about, specifically implementation of RPKI variations and how to filter the announcements using RPKI. So that lab is a lab that uses remote routers. In the morning, we'll also try to explain what the procedure is like to connect, the topology of the laboratories that you're going to do. And with that, we'll be able to do the hands-on activity. Those of you who can follow us can do so, and otherwise we will be explaining this. So now I will connect to the Zoom to show the presentation. Silvia and Santiago will be joining us this afternoon, so they can now be free to go down and sit with the audience. Creo que es el único lugar que...
Bueno,
So can I have the presentation?
no sé si pueden poner la presentación.
Can I have the presentation, please?
Bueno, mientras voy hablando un poquito de
So while we wait, I will tell you what we expect from this tutorial. So what I'm going to be commenting on now is how interconnection is evolving in the internet, and also about the initial stages and how this has evolved towards decentralization and content distribution towards the network borders. So it is important to bear this in mind, because that is when many of these things become meaningful, many of the things you will be discussing now. For example, the issue of content distribution and content networks such as CDNs and local connection at the traffic exchange points. So all that takes place, and in our region specifically, this has grown a lot. Content distribution towards the rest of the network. So this allows us today, this allows the traffic exchange points to grow at present, and content can be accessed locally. So what I was saying, so here we have the slides now.
me desconectó. Tenemos algunos problemas. Se me desconectó el Zoom. No sé.
So Zoom apparently disconnected.
A ver ahí. Bueno, ok.
So what I was saying,
Tradicionalmente, ¿cómo se encamina?
so how does traffic take place in the internet traditionally? Normally, these are autonomous, interconnected systems. These are different autonomous systems that interconnect with one another. Normally, we have content providers where the large number of content is located. These can be different providers. These are not only commercial providers. These are also sites that have content, and there are also sites that have users and access ISPs where we have the eyeball networks. These are the networks where the users are located. So this is a visual division that is made. We have ISPs where the majority of users connect, and there are others that provide content. So each of these will have a transit provider, a higher level provider, both for contents and ISPs, and then all the autonomous systems connect with one another. This is the more traditional way. So what happens when this traffic, for example, starts to grow? If the content of this provider starts to grow, then this provider will have to expand its links. It has to expand the transit links so that they can reach the other end and does not become saturated. This traffic grows. And at the same time, if there is a greater consumption, then the providers that have the users behind them also have to expand the links with the traffic providers. And the traffic providers will also have to expand the links to the internet. So as you see, as traffic increases, each of them has to pick up the traffic links. This is a more traditional type of model. Now, what alternatives do we have? What started to happen? The larger content providers saw that it was more efficient, instead of increasing this transit network, to directly reach the users. So instead of following and increasing all this path over here, what they sought was to have a more direct connection to the networks where the ISPs are located. So this is how the issue of content distribution came up towards the borders of the network. This has many advantages because for the users, the content is closer to them, there is less delay, and they can provide more bandwidth. And for the user experience, this is far better. So the content providers seek to have that. They seek to be closer to the end user and reduce costs at the same time, because when they have to expand this link and not everything that is in between. So that is the option, and that is where internet is heading. You probably have heard about edge networks or content distribution towards the edge. So how do we go about that interconnection? I will now give the floor to Erica so that she can tell you about this. Good morning, everyone. I hope you're all fine. So let me now speak about the different interconnection options we have. The first one, which is the one that is most used, is the direct interconnection. This is when physically we do peering interconnection with another autonomous system with which we have to exchange some kind of traffic that is generated through our network. So here in the topology, we see the different autonomous systems and so on, ISP A and ISP B, and through physical interconnection, we will do the data transfer and information transfer. Now, one of the problems of this type of direct interconnection is that it can be a bit too complex. We always have to identify these physical points that we wish to have in order to establish that interconnection. Therefore, with the different providers with which we wish to establish it, we have to figure out the way of reaching physically the nearest node and establish the different types of interconnection. So looking at this topology, we'll have quite a number of links with the different autonomous systems that might be in the network. So we lost the connection with the Zoom. I can only see myself on the screen.
Ahí está. Gracias. Así que es
Agenda.
que queremos.
So what we wish to achieve is this direct interconnection. The other model that we have regarding interconnection is the model of public interconnection. In this model, once we can have it back on the screen, the idea is that in a community that wishes to transfer different type of traffic and have different agreements, we'll have a specific point where we will have various internet service providers, different autonomous systems, different networks generating traffic with one point, interconnection point, and then we can speak of examples. It's not only these IXPs that we have, and we're understanding more and more how relevant they are, these traffic exchange points, but this public interconnection that we can have with providers, with content providers, such as Microsoft, Google, Facebook, which we know have a database where these nodes are hosted for the purpose of information exchange, and that is where we'll be able to establish the interconnection and not only having access to this specific service, but to all the traffic that is dealing with the interconnection in this public interconnection system.
Vamos a esperar un poco porque quiero que vean, alcancen a ver el slide del esquema de interconexión pública.
So we are going to see until we're waiting for the slide before we speak of the CDNs. Well, while we wait for the slide to show, so as we see all the growth of traffic that we've had in recent years and all the accelerated change and how all the traffic has grown and the bulk of information that is handled, it is then that these infrastructure, these engineering infrastructures appear, that is the content distribution delivery networks that specifically aim at bringing contents to users. The idea is to enhance the service and to reduce to a minimum the lags, the latency, the time that it takes for the information from the server to the end user. It is thanks to these CDNs that we'll see an infrastructure, these content delivery networks, we'll see that we have an infrastructure for content delivery and we'll send it to the end users. So with the growth of all these new infrastructures of the CDNs, we gradually see the need to sign various agreements to deliver content through these CDNs. An example of the best known CDNs, or the so-called traditional CDNs, well, you can see Akamai, Cloudflare, Layer 3, and
Un momento que se cayó aquí la conexión.
sorry, because the connection crashed. And I think it won't be a good thing if you don't see the presentation while I speak.
Es que la red se cayó. La 2.4 está
2.4, Luckner 2.4, is that the web? Is that the connection that we should connect to?
vamos conectándonos nuevamente, no faltan los problemas técnicos.
We have some technical problems. Bear with us.
La 2.4 te conectó. Vamos a esperar un momento porque tenemos algunos participantes remotos.
Let's wait just a minute because we have some remote participants.
¿Cómo? Vamos a... No, es que la 5.0 está súper baja la señal.
Hola Guillermo, Erika. Aprovecho para preguntarle si me escuchan ahí en la sala.
Bueno, les voy, así como les estaba
So, as Guillermo was telling you, in this first part, the idea is that we'll see all the theoretical part and I'll walk you through the tutorial to tell you all of the topics that we are going to discuss. Then we'll have a break and we'll have 2 Kahoots when we finish all the theory, and then we'll give you some prizes. And in the afternoon, when we have the hands-on part after lunch, we are going to finish with one of these games, and you're also going to have prizes.
Y si no, vamos a tener que pedir un...
And if not, we'll have to ask for a whiteboard. And I can write it down in the whiteboard.
Me va a conectar con los datos de mi celular. pero ya aquí. Vamos a ver. Ahí. Listo. Creo que para los del Zoom ya está la presentación nuevamente. Solo falta aquí. Ahí está. De vuelta. No. ¿Y acá? Acá. Ya. Ahora sí.
Now let's resume again. So, we were talking about the content delivery networks, and I was giving you some examples of CDNs, the most traditional CDNs we are familiar with. So, let's see the differences between the CDNs and the content providers. We also have some companies like, as a matter of fact, Google is a company that has produced its own content delivery network and cached servers, and they also provide their own contents. The traditional CDNs, we have these ones here: Akamai, Cloudflare, Level 3, Limelight Networks, and content provider-owned CDNs such as Netflix and Facebook. So let's see what happens with the internet traffic at present, and why is it that there's such a massive increase of all these contents delivery networks. Something that is absolutely true is that a terabyte is no longer what it used to be. We have turned into heavier users, and each internet user generates more and more and requests for more and more bandwidth to have access to the various contents or resources that they want to use. So you see that 34%, that's the increase of bandwidth from 2019 to 2020, and by 29%, an additional 29% in 2021. So a lot of, we all saw this occurring during the pandemic, and all the increase in the traffic and contents that increased so much, especially video streaming. And indeed, we see the different categories that we show here, that video is the category with the greatest share in traffic globally. It accounts for about 53.72%. And this in a study that was done for traffic for early 2022. Then we have the social media. And you may, and through the social media became a tool for work where we can send videos, audio, and this has led to the increased use of all the tools in these platforms, in the social media. So, and at the same time, there's a huge increase of the traffic that they have generated, and we see how gaming is increasing more and more because of all these games and simulations that these platforms provide you with. At present, they're called the OTT platforms. The platforms that deliver contents and data, but not through the means that we knew in the past. That was the TV set that gave us the possibility to use a video, but using the internet resources. So we see that the more bandwidth we provide our end users, the more they're going to consume. More and more contents that is generated as videos increases significantly the megabits that are used for streaming all this information. So we have an increased number of internet users every year, thanks and owing to the pandemic, there was an accelerated growth in these 2 years, but streaming contents continues to grow. And we see these representatives and identities that provide all the video content. Ranking first is YouTube. And you see the top 10 choice of various platforms that generate different content spaces. But here we are only showing OTT platforms. These are the platforms that produce contents, that generate contents, and send this service through the internet resource.
In terms of video quality, we've seen a major change because when we started with video streaming, this was a standard quality. And now we have videos that are HD, 4K, 8K, 16K quality, which will be using more and more bandwidth for the purpose of transporting this type of data. So being aware of the reality we now have and the amount of traffic that is generated by all these content providers and also requested by the end users, this shows that all these traffic models require having agreements with the different providers. And as providers, for example, of internet services, and we have a lot of clients, we have to improve the user experience, the end user experience. Let me rapidly speak about the content delivery models in the CDNs. We have the pull and the push models. In the push model, these content generators send traffic to cache servers in order to bring them closer to the users. The content hosted in these cache users follows a series of algorithms to see which is the content that should be closer to the end users. And then when an end user wishes to access that content, they can do so because it is closer and the user experience is better with that quality of service because the latency will decrease. In the pull model, we note the difference. This will only be sent when requested by the user. In this pull model, these content providers work as follows. The user requests the content. It is sent by the origin server where it is hosted. It is sent when requested by the user, by the end customer. It is then stored in this server from which it was sent, and in the intermediate caches, so they can also find it a bit closer as users start requesting that information. Now let us look at some basic definitions that will be explained by Guillermo in order to go over to the security part of the presentation. Now let us speak about some basic definitions of concepts that we're going to be using during the tutorial. It is important that you take these into account. We're going to speak about transit. When we speak about traffic transmission through a network, and this concept is directly associated to a cost. This transit can be to different places. Normally, transit links are what we call internet. When we speak about transit links, we're speaking about a provider that gives us access to the internet, and we have to pay for that service. Then we have peering. Peering is another concept that is quite different. In peering, we have information and routing exchange and also traffic exchange. When we speak about routing information, we speak about BGP and traffic. This is between two organizations that agree on connecting with one another and exchanging traffic, but not providing internet transit to any, but to connect two autonomous systems. This is quite common when two major providers have a lot of traffic between the two and they decide to have a peering relation. Instead of using what we saw initially, instead of using the internet transit links, they establish a link between the two so they can then download the traffic, and the traffic that became saturated is now obtained directly. We should also be aware of the fact that peering is between organizations that connect to one another and can provide access to other autonomous systems that are also connected. But they should not convey traffic from the higher providers. We'll see that in greater detail later on, but that's a basic concept. One thing is transit, and another thing is peering. We're also going to be speaking about the default-free zone. These are the autonomous systems that do not require a default route to reach any destination in the internet. So these are the level 1, tier 1 providers that are those that reach all the levels. There is another important concept, and this is to distinguish between the words transit and transport. This is also conceptual. Transit is usually a tier 3 service. It can be through BGP or not. A provider can provide a service that does not require BGP. So that is what we call transit. When you hire a link from your organization, a link to the internet, what you normally hire is an IP transit link. And the cost is based on megabits. This is a megabit per second cost. This is useful when you have a link, and this allows you to use the internet. You can send traffic to many sites and receive from many sites too. Traffic depends on who provides the service as an upstream provider. In the case of transport, this is in a different layer. It is tier 2. This is a more physical network. Here you have things such as Metro, Ethernet, SDH. Today, Metro Ethernet is what is most used for layer 2, for tier 2. This is a fixed cost per capacity. You're not paying for the use of megabits. You hire a fixed amount, for example, a gigabyte, 10 gigabytes per second to connect to sites. And then what will occur is that you can use all the bandwidth. For example, if we hire a 10 gig link and I'm using 10 mega, I'm just underusing what I have hired. So we would like to make maximum use of that link. This is justified when traffic exceeds a certain amount that then justifies hiring that type of link. So this traffic is between organizations that establish the transport traffic. This is a point-to-point link, not like the previous case where you connected to the internet and you have access everywhere. This is between two different organizations. So the next slide, please. Traffic exchange points. As Erica was saying earlier on, the direct connections, the peering, when you don't wish to connect to many organizations, this does not scale up very well, because you'd have to establish the following. If the transport links are between two organizations and we have to connect to 10 organizations, we should have 10 transport links, which would be very expensive. So many alternatives arise. One is a traffic exchange point. There are other options, for example, data centers, where operators can interconnect, or co-location points where you reach with your fiber, and there are other operators, and you can have agreements there. But the IXPs have been in the region for quite a number of years. In the past 2 to 3 years, there has been a major growth. New IXPs have come up in countries where these did not exist in the past. So what are the IXPs? These are sites where the network operators interconnect. They have other names. In some places they're called PIT, Traffic Exchange Point, PTT in Brazil, Ponto de Troca de Tráfico, NAP was used in the past. So basically, this is a type of infrastructure that is used, that is shared between the different members in order to exchange traffic. Now, what you see here is also important. Who are those who exchange traffic? We have content providers, ISPs, but other organizations as well who have a lot of traffic in the region. For example, universities are normally located in traffic exchange points. Media sites, banks, for example. So that is important, that all participants who have content should be connected there. One of the things that is typical of the IXPs is that there are several autonomous systems that interconnect. There are not two, but there are several. Another important thing is what we have here at the end. An IXP is different from an access network, and very often these are confused. When new IXP projects begin, they think about providing internet connection to its members, but that's not the goal of an IXP. An IXP should not provide internet connection, save for some services, for example, DNS route servers, or some kind of service that provides services to its members. But it should not provide transit, what we're speaking about today. It should not provide transit to the autonomous systems connected to the IXPs. The role of the IXPs is to connect networks, not to provide access, nor be a transit provider or a carrier. So they interconnect with one another, but they don't go out to the internet. They should not go out to the internet in that way, in that mode, with that option. And they're not access providers. They're not going to provide connectivity to the end users. IXPs are there to exchange routing information and traffic between the member organizations of that IXP. Can we have the next slide, please? What are the advantages of the IXPs compared to other solutions?
The local traffic is routed locally, and that essentially is the main feature. So that greatly improves the stability of routing and its resilience. So the apps we'll have shorter latencies, costs will go down, and now we have the chance for the CDN to get installed in the IXPs, because as Erika said, the CDNs like to get installed where there are many end users. So what typically happens is that they install and they put their equipment, the CDNs put the hardware, but they need investment for that. And they do that when they're sure that they will have many users behind. Remember that the networks that we showed at the beginning, CDN will go to the IXPs with many users. So if there are small IXPs, they won't have, the CDNs won't be so interested. So one way we can attract them is through IXPs, because there all the small providers will be connected. So although each one individually does not have so many users, by being together, they'll get a good number, so the CDNs will be more interested in investing. On the other hand, that the traffic of a region or a country is not accessible from other sites, that is also important, even from a point of view of security and stability of the network, because we don't route through other autonomous systems to take local traffic, but we exchange it locally. And then the community feeling and the possibility of introducing new technologies such as IPv6 and RPKI. It's easier to do it in an IXP where we don't have, where the IXP is not the link. Let's say that it's, if, for instance, if the IXP connectivity gets interrupted, you still have the transit possibility to go out. So you can do more novel things with the IXP. And the community feeling or sense, I want to highlight this because after several years of operation, IXPs started forming a community where they exchange and share both technical and other kind of problems that they have. And it's good for them to get together. Now, speaking of costs, we already mentioned this when we talked of transportation, but in the case of IXP, we have costs that are usually fixed, flat costs. If an operator wants to connect to the IXP, they have to pay for a transport link, and that is per capacity, 1 giga, 10 gigas of a flat fee. Then we have the co-location and the hardware. If you have to put a router to connect to the IXP, the cross-connection costs, and usually IXPs will have a cost that is a fee that is charged between the members for their own survival. So IXPs, to survive, need to have a business model enabling them not to disappear. So that's why they establish fees, and typically people try to to keep it inexpensive, and those are fixed costs. And here there's a cost. As you use this more and more, then it gets justified. Because if the cost of transit is that line there that says transit price, the horizontal line, as the traffic increases, then you'll save more, and it will be better justified to connect to an IXP. If we don't have much traffic, remember that we have flat fees to pay overhead. So in a 10 giga link, if I only use 500 megas, it's not good business. But if I'm closer to 10 gigas, if I'm 7, 8 gigas, certainly there I will be in that part under the curve where the cost of peering or IXP connection becomes more efficient, and it's a good thing to do it. So that's the idea. And why do we speak of cost? Because actually, when you do peering, when you connect to an IXP, you don't only think of it from a technical point of view, because from a technical point of view, everything looks pretty, but if the figures are not good enough, you won't connect. So the flat fees or the overhead needs to be as low as possible. If I want to connect from home to the XP, then it will be very expensive. But if I'm a larger organization with a lot of traffic versus the autonomous systems that are connected there, it makes sense. So that is the analysis to see who is there and who will I be able to do peering with. So I have these content providers, these operators, etc. So I'm going to be able to reduce IXP cost, transit cost, and go through the IXP. And it makes sense. It's good business. From the technical point of view, how does it work? Well, basically, the most basic thing is a switch and router of the autonomous systems. This is ultra simplified, of course. Of course, the IXPs, as they grow, they get increasingly complex. So instead of a switch, they have a switching fabric of several machines that they can work in layer 2 or work with different technologies. So it may be layer 2 over layer 3, but this is the key idea. Operators connect, they log in through a layer 2 switch, and each has the routers connected there. That router can be in the IXP or in the operator's network and reach with a fiber to the IXP. These are different alternatives. The important thing here is for you to see that the operators connect with each other through the layer 2. So what are the problems that we may have? In the previous slide, we saw 4 autonomous systems. Now, if I have many autonomous systems and I'm connected in layer 2 to raise peering and to establish BGP sessions, I have to do it in layer 3, and I should do a BGP link with each of the routers of all the different operators. And if I want redundancy, I would have to put 2 BGPs configured with each of them. If a new operator comes in, they have to raise a BGP against all the rest, and each connecting to with a new one. So that doesn't scale up nicely. So what do people do? I wanted to show how that problem gets solved with route servers. That are servers specifically. Let's see whether we get the slide back.
Dale. El número 20. No, ese número no es. 28. Dale, con este. ¿Cuántas son? 45. Bueno, road servers entonces.
So route servers, when we want to solve that problem, what we do is use route servers in an IXP, where what we put there is a server, and the BGP sessions get established with the route server. So each autonomous system will establish a BGP session against the route server, and that will reflect what they receive to all the rest. it's such as a BGP reflector router, but in this case, it's an external BGP. These are external BGP sessions. So the autonomous system teaches 100 teaches the servers each teach their routers, and the route server replicates it to the rest. So each one gets a session with the route server, teaches the route, and that's how it's simpler. So you may think, well, what happens with that route server? Well, this machine, the only thing that it has to do is to take the BGP traffic, that is to have the routes and exchange the routes with all the rest, but the traffic itself will go through the switch. It won't reach the route server. The IXP traffic would go, for instance, from between 100 autonomous system and 400 will only go through the switch. So the switch does need a significant switch, but the others, not the route server. So the route server can be just a server that runs software-based service. So we'll see that there are some software-based, and the server doesn't need to be an extremely expensive server. It suffices with a good memory to support the routes of BGP, because the data changes, but it doesn't send any packets. It has several advantages, including one of the main ones is that it enables you to establish filtering policies with the software already available today. You can implement filters that prevent misconfigs, or to implement RPKI filters. And so here we have two very popular examples of root servers. The first is a Python tool, and the other one is being used by many of the newest IXPs in the region. We've worked together with LAC-IX and the Internet Society at LACNIC to provide support to new IXPs in the implementation of these systems, to organize their traffic and to organize the way they administer the IXP members. So what this software does is to produce IXPs for BERT or other software-based BGP by implementing many of these characteristics that I mentioned. And finally, interconnection. Not only do you interconnect with a route server, that is a multilateral agreement where each organization connects against the route server, but in the IXP there may be private agreements. That is, here the autonomous system 200 and 400 may have an interconnection agreement through BGP privately, and they don't need to go through the route server. So here you have the definition of what a multilateral agreement is. A bilateral agreement. In the bilateral agreement, two organizations reach an agreement to establish a BGP between them, and in a multilateral, they connect with the route server, as we said. Here you have references of the campus courses and some RFCs for routes on route servers. I don't know whether there are any questions so far. Now we'll give way to, well, questions. There are microphones here. You can stand up and get closer to a microphone. And through in the Zoom, I don't know, Erika, whether there are any questions in the Q&A panel. If there are any, then we can proceed to answer them. So let's go first to that question. Can you enable the microphone, please? Good morning, Guillermo and Erika. Introduce yourself and say, I'm Carlos Sanabria and the manager of Bit Bolivia. Guillermo and Erika, could you expand on the bilateral peering issues? What are the advantages? When can they be restricted? In our case, we only do multilateral peering, but we have detected that sometimes between IXPs they do bilateral peerings. So could you expand on that, please? Yes. So with regard to that, this is an endless discussion, and there are different models. You don't have a single solution. There are IXPs that only allow multilateral agreements, while other IXPs permit the two, and there are IXPs that force you to go multilateral or bilateral. There are some IXPs that allow you to have bilaterals and others don't. Why is that the case? Well, actually, the IXP members may have different needs. So usually, small operators benefit from the multilateral agreements because they can connect with everyone, but there may be large operators that may be willing to have bilateral agreements because they share a lot of traffic, or they can establish a BGP link and they start routing their traffic through the IXP. So that is beneficial to them, but that is something that, as I said, has to be defined by each IXP among its members.
The IXP has to benefit its members, and the members have to perceive that they are benefited by the IXPs, otherwise they will not continue. So this requires discussion between the IXP members in order to make a decision that does not affect anyone and is for the best of all. But that discussion normally takes place and in both directions. This is something that they have to discuss with one another. But yes, bilateral agreements is something that has to be discussed because the major operators very often seek that when they have a lot of traffic between two autonomous systems. In that way, they connect with one another using the IXP network. We have questions in the chat. Hi, can you hear me? We have a question from Luis Arroyo in the chat from those who are following us remotely. He says the route servers are for exclusive use of the IXPs, or could they also be used by ISPs too? Well, that's an interesting question. The point is that the route servers normally are focused on IXPs because they have the external ones in an ISP network because it is all the same autonomous system. They use the internal BGP. So what we use is a route reflector and not a route server. But yes, one can use route servers, not with this kind of software, but for example, software BGP in order to inject the routes in my autonomous system with an internal BGP. But it is no longer, I think it's not meaningful to use that software for that purpose. But if you can use Open BGPD or FGR, but BIRD, for example, Open BGPD, to implement a BGP software-based service and inject the routes from there to announce these to all the routers in my network. So I generate the routes there. I'm not generating the routes in the routers, but in a central server, and from there I can control the announcements that I do in my network. So that's quite a common solution. So microphone. Good morning, can you hear me? Yes. I'm Julian Latorre. I am part of the fellowship participants from the north area of the Cauca region here in Colombia. So thank you very much for your presentation. I have a question in the sense that what you are telling us about the route server has a proactive or reactive protocol to complete the routing list. Can you use the two types of protocols? How do they work? In the context of an ad hoc network or a high mobility network, if the links are not reliable, how do you guarantee filling the routing tables in an efficient manner? Well, you should think that this has been considered for IXPs, so the route server will be in a local network, and the connections are Ethernet. They could be gigabit Ethernet, for example. So all is connected locally, so it shouldn't crash. BGP manages the route servers. These are the sessions compared to the members of the IXP. So through BGP, you will learn all the routes, and if a member gets disconnected, they will no longer have those routes, and it won't be reached. Basically, it's that. I'm sorry, the person did not use a microphone. BGP is when something gets disconnected, and those routes are eliminated from the routing table. We have another question. Let me remind the participants who are following us remotely to make your questions and comments in the Q&A space at the bottom of the screen in Zoom. Elliot in the chat says, hello, good morning. I'm Elias Mayorga Velázquez from the Cocavisión Ecuador group. My question is, what incidences, most common errors, if you can mention the top 3 of the list, occur when you do bilateral peering?
Incidencias.
Bueno, vamos a dejar eso para...
We're going to leave that for the second part of the presentation. We'll be speaking about all those topics. Now let us have the last question from the room. Good morning. I'm Carlos Berna. I work for Renet in Venezuela. My question is the following. In a platform we have CDNs like Meta or Netflix. How could these systems help us? You know, route servers and the IXP that was mentioned in the presentation. This would help us make that peering with other providers locally, or how would this be helpful for us? Thank you. Well, the route servers, these route servers have been considered for IXPs. When you have the CDNs in your own networks, this would not contribute anything. The route server will be useful to organize the traffic in an IXP. It is very specific for the IXPs. What I was saying about the CDNs is that many smaller operators are unable to make larger CDNs like Google. I don't know how much, as a minimum, they are requiring in terms of bandwidth to get connected, but about a 10 giga link. So the smaller providers won't have that traffic with Google. But if a location you have 10 smaller providers, well, maybe there it is meaningful for Google to install its caches or do a peering with the IXP, because there you concentrate traffic from many autonomous systems, and when Google measures this, they will say, well, I have autonomous systems A, B, C, D. Together they amount to 5 gigas. It's not what I want, but it's not bad. So we can have an agreement with them. And this is how this is working in many of the IXPs. The caches, the CDN operators install the caches there. Somehow motivated by the growth they expect that IXP to have. We have another question from a remote participant. Good morning. I'm Enrique Avila from Global Fiber Peru. Question: can I implement a route server to be able to receive all the internet routers of my ISPs and announce full routing to the clients who request this from me? This is so as not to depend from very large and costly networks on the edge of our network. So the route servers have been conceived for IXPs. If you have a server that announces routes, you might have to think where the traffic is going through. If it's not an IXP, then the traffic will end up going through a server, and that is not what we like or what we expect. So let us continue with the presentation. Otherwise, we won't have enough time, and then at the end, we will continue with the questions. So now let us have a look at routing security, and in the context of what you were saying before, the types of incidents and problems that could come up. There are two basic problems, routing problems that have to do with this. One is route hijacking, and the other one is route leaks. What is route hijacking? This is the action of announcing prefixes that we're not allowed to announce. This can be both intentionally or through errors in the operation. Route hijacking does not always imply intentionality. Very often these are errors in the operation. What does this consist in? Well, you know that BGP does not control who originates a prefix. Any autonomous system can originate a prefix. There is no control, and you can say, well, this does not belong to that autonomous system. The autonomous system can originate a prefix. So let us assume here that client you have here, which is a mobile phone connected to the autonomous system 65501, wishes to reach that prefix 2001 DB8FF0020, and then how will they be able to reach there? The client is connected by default to its internet provider. This could be a home user. They will send traffic to autonomous system 65501. 65501 will have the two networks you have there, 2001 DB8FF040 through 65502 and 65510, because it learns it from the 510 and 502. They learn this through BGP, and the other IP network that it learns from below, 65509, sends a sign to 502, and that to 501. So normally, the client will send traffic to autonomous system 65501. This will see the first network it has there, and then we'll send it to 65502, and 65502 in turn has the same network in its routing table, and will send it to 65510. They'll have the same route. So that is a normal process. Now, what happens if the 65509 starts to announce this prefix, the 2000 DB8FF00, but more specifically, it announces a /48? If there are no controls, 65502 will just accept that prefix if it has implemented. Well, let us assume that 65502 only implements a filter by autonomous systems. So I'm going to allow everything announced by 65509. So 65509 starts announcing the /48, and it goes to the routing table of the 65502. And 65502 announces this to 65501, and in turn, this one accepts it and installs it in its routing table. Now, what will happen when this sends packets to 2.220? Obviously, it will use a more specific route, and the more specific route is 48, the 48 route. So there you have what we call route hijacking. The autonomous system 65509 is detouring the traffic through announcing a more specific prefix. So 65509, with that traffic, we don't know what it will do. it might occur that I will be trying to connect to a bank, and instead of going to 65510, I'm going to 65509.
I could have a fake page of the bank there and take all the data, or I could reroute the traffic to the internet and analyze it, inspect it, etc. So that's route hijacking. Now, the other common case is that of route leaks. These are route leaks. That is, it has to do with what we said earlier today. When you have a peering, let's assume that between 536 and 37, there's a peering relation. Nobody should be able to see what they do between them with the upper. Let's say that 311 is a transit provider to all. What they learn from each other, they shouldn't take it up. For instance, this announces this /40 and learns 2001. And each announces its own prefix upwards, but not the others. If 65337 lets the /40 go by, then there's a leak. So the very common thing is for these leaks to occur in the internet. What is the problem that it causes? Again, the traffic going to the autonomous system 6536 could be going through the longest route. And that causes a lot of trouble. First of all, it gets everything. There's too much traffic going through a place where it shouldn't. So again, it can get analyzed and processed by with other purposes. Security incidents. Well, I leave the slides for you to see later. This shows how we've seen a routing incident reduction in later years, and as a consequence of the adoption of protection actions. And here there's a slide I brought from Manners. What this slide shows is that although there are still many routing incidents, they have a smaller impact because over 70% of the incidents were detected by less than 20 BGP peers, detected by BGP collectors globally. So it's as if the extension, it doesn't spread as much. When an incident occurs, it encompasses fewer than 20 peers, so it gets stopped faster. These figures in previous years was smaller. It had a much greater impact. So as the figures go up, it's worse because it has an impact on more autonomous systems. So when there's an incident, it is detected, but it affects fewer autonomous systems than in the past. What can we do to mitigate the incidents? Well, a number of good practices that we follow is Manners. So I won't say much about Manners, but it's a set of recommendations for operators that has several parts. Essentially, it indicates the actions that operators need to adopt to protect their networks. Filtering, anti-spoofing, global coordination for the operators to be coordinated and connected, and so they may have they may update their contact data. So if there's an incident, they can connect with each other. And then the other one is the global variation. That is what we will discuss now. There are also specific programs for IXPs. So, this is related with what I said earlier about the leaks. What are the things that should be announced and what are the things that should not be announced? We have peering links and transit links. Here, for instance, let's assume that a client of 61501 announces a route. Where is it okay for 65501 to announce it and where not to? In this case, 65501, if it's a client of 65501 to internet, to a transit, it will be announced, and that's okay. And with the peering too, because if we have a peering, we want all the networks in our autonomous systems and the ones that are connected to be announced to the other organizations. Now, 65502 should not announce what it learned to its own peering links or other transit links. So these two would not be nice to share. So, in turn, if I learn from my transit link, that is my internet provider announces routes, where should I announce them? Well, to my own customers, of course, for those that have BGP with me so that they can receive those routes. I should not announce them to the peering links, and this is essential. What I learn from my transit provider, I should not show through peering. And in turn, what I learned through peering, I announce it to clients, but I do not announce it to transit or to other peerings. Now, these rules are a bit the key to prevent links from occurring. Now, the question here is, can I put filters and define when I'm going to announce things? Now, how do I know what things I have to learn? For instance, in this case, if I'm in 65501 and I configure a peering with 65502, now what do I have to learn from 65502? And then whatever 65502 shows me everything. But we saw there are problems. And if there's something behind 65502, do I have to learn that? Well, I don't know. There's no way I can know. So how do we do that? Well, there are two ways. One is RIRs, and the other one is RPKI, Internet Registries, or RPKI. So as we said, BGP does not have any mechanisms allowing me to vet this, so I need to consult external sources. So the BGP announcements, we can consult in the RIRs. These are charts developed many years ago, ever since the 90s, with the Internet Routing Registries, where autonomous systems register the networks they will announce with their autonomous system. And others, they can consult what are the networks that 65502 will announce and will know which they are, and may configure the entry filters. Luckner has an RIR. Well, this is a sketch of how information is in RIR, how to use the information, as we said in this example. I didn't know what I had to learn from 65502. I can generate a roadmap. No, not a roadmap, he corrects. And as I said, in 65502, this is a type of object that lists the autonomous systems, a set of autonomous systems. So if in 65502 I list the autonomous systems that I'm going to give transit to, I say autonomous system 65502, transit and the members, then 65501 will be able to know that the autonomous systems that 502 gives transit to are those three listed there. And it can configure the entry filters, and this can be done automatically with software. For instance, this BGP4 tools, BGP3, BGP4, with those commands there, directly generates list of access, taking all the autonomous systems listed in an ISET. That's one way. So this is very common when today the CDNs such as Google or Netflix are requesting this type of I said for you to register it. Then I'm going to leave a link. There's in Lacknick Labs, there's an article that tells you how to do when you raise appearing with Google and they ask you to generate an ICZ or an RIR. So there you have the documentation. The other way is by using RPKI. RPKI puts together a public key infrastructure to associate certificates with the resources delegated by LACNIC. When LACNIC gives organizations, ISPs, or end users, they give them resources, together with that, they give a digital certificate that to prove that they are the owners. What is that used for? Well, as you know, the certificates are an association of a couple of keys, public and private keys with the resources in this case, and the organizations receiving the LACNIC's IPv resources, IPv4, IPv6, will be able to sign these objects, that is, the ROAs, that will allow you to define the autonomous system of origin with the prefixes. So it's similar to the RIR, but here this is more robust because it's signed digitally from the security. So only the one who has been delegated a prefix, for instance, IPv4 prefix, IPv6, only those delegated the prefix will be able to do that ROA. On the other hand, all that information is public. It is copied in repositories. So we are going to see this afternoon at the lab. You'll see how you can have access to that repository and how to validate. Once you bring all the ROAs and you receive a BGP update, you can compare that versus the ROA and see whether it's been well announced or not. So basically, it's an external check versus an external database of the information that we receive through the BGP. So that is the source validation. The repositories are in LACNIC and each of the regional registry. You install a software that's a validating cache. You bring the repository and you feed the routers, and then the router, when the router receives a BGP update, they'll be able to check against that information, that database. Now, when the routers have their caches, the ROAs are like this: a prefix, length, a maximum length of disaggregation, and the autonomous system, the source autonomous system. There are hundreds of thousands of ROAs. I don't know how many there are in the table now, but there may be, for instance, 100,000. So that will be generated in the validator, will feed the router, and when you receive a BGP update, you'll have a table. So if I receive the prefix 200.102/25, it wouldn't be correct because I'm saying my maximum length should be 24. Now, if I received /24/22, but with the source autonomous system 65502 or 503, it wouldn't be right either because I'm saying that the source autonomous system is 65501, and who's telling me that? Well, the one that has the prefix 0212 assigned by LACNIC. That is, the organization receiving that prefix from LACNIC has to generate the ROA saying that. So then all those with BGP will see that if it comes from another autonomous system, they shouldn't receive it, accept it. So we have a validity status that is valid, invalid, or not found. So let's stop here because we now have to go to the break. But let me give you some housekeeping announcements before going to the break. But we'll go on. After the break, we'll go on with BGP and RPKI in practice by Eric. Now we have a 30-minute break. We'll be back at 11:30. Now we invite you to visit the Luckner booth, so where you can ask about the Luckner campus. All these topics are visible in the Luckner campus, the online training system offered by Luckner. It's there for you. There are the different courses, IPv6, RPKI. I invite you to visit us, and we'll resume at 11:30 or 4:30 UTC for those of us in remotely. Thank you.
back in Boston, you didn't know what to do. So, she says, let's just wait it out. You know, we can be all poetic and just lose our minds together. Hey, wait. I wasn't alone. So, I'm still waiting for my turn. Hey, wait.
silver is gold, though we're much too old for make-believe. I know what it is to be broke and be bold. Tell you that my silver is gold, though we're much too old for make-believe. I know what it is to be broke and be bold. Tell you that my silver is gold, though we're much too old for make-believe.
You ever have that feeling where you're not sure if you're awake or still dreaming? All the time.
Hola, hola.
Hello. So we will now resume with the tutorial on towards increased security in interconnection and peering. We'll now continue with the presentation. There were some slides pending. These will be presented by Erica. Now we will be speaking about how to create the ROAs and the RPKIs. Erica now has the floor, and then Massimo will continue after Erica.
Hola, hola. Ahí está.
Hello. So we now continue with RPKI. Remember that in the last part, with validation of origin, we're now speaking about the security scheme that we can have in our infrastructure, where we can create something that we call digital certificates for routing, which are the ROAs. So he, in general, described how the validation infrastructure is, which is what we saw here in this part here. Here we saw what the traffic was going to look like so that we could do validation. So if we focus here, and this part will have a team that will do validated cache where we have validated those digital certificates that we create. These certificates will be consulting in the validating cache in a global repository that each internet registry has. These certificates will be hosted in our validation servers, which are in our infrastructure, physically in our infrastructure. And these are updated with the information in this global repository, depending on how we configure these. Now, once we have these certificates hosted in the cache server of our infrastructure, our routers, when we activate the RPKI protocol, they are going to consult this validating cache will consult this at all times in order to identify if the information in that certificate and the information is valid or not valid or not found. Remember that with the validation system, what we want to do is that our resources, for example, IPv4 addressing, IPv6 addressing, stating what we are publishing, the segments, MV4 and V6 from what origin, and the origin will be the autonomous system from which information is sent out. So based on that, we're going to make decisions and understand how we're going to be doing the monitoring and visualizing the information in our routers, which is an additional attribute in our BGP table. As I was saying, the caches are all the time bringing these certificates to a validating cache, and through a protocol called RTR, they submit the information to the routers where we have the RPKI protocol. So first of all, those of us who own resources have addressing resources assigned to us, IPv4, IPv6 resources. So first of all, we have to create our ROAs. What we are going to do here is to indicate with what autonomous system we are conducting our announcement. The clients or the networks that don't have their own resources assigned from LACNIC, in this case, for the Latin American and Caribbean region, they will depend on their ISP so that they can generate these digital certificates depending on the addressing, IPv4 or IPv6. Each of these resource owners will be responsible for creating the registers and updating them, so depending on the changes that take place. So what do we have to take into account to create these ROAs? First of all, is how we are making the announcements. If we receive in IPv4 a segment 19 or 24, how are we segmenting this to deliver the information, and how are we making the announcements? So depending on that, we'll indicate whether we are publishing this with the entire pool in a summarized way, or if we are breaking it down. If we are breaking the pool down, in general, we have to create each of the certificates depending on that disaggregation of the segment, both IPv4 and IPv6. And the second point is to know and to identify with what autonomous system we are making the publication of our traffic. So if we have our own autonomous system, this will be with our own autonomous system. We'll be using it to create the digital certificates. If we are working with a traffic provider that is providing their autonomous system to us, have to indicate that our resources assigned to our entity will be announced through the autonomous system of my service provider or my transit provider. That is how These are the 2 points that we have to bear in mind when we create these certificates. If we don't respect this policy and if we make mistakes, then these certificates will be considered invalid because we'll have a register of the announcements that are being made. They are going to be checked in the database, but the information of the prefix will not match with the announced one or with the autonomous system that should be allowed to make that announcement. Let us take a look at an example. Peering, we have a physical interconnection, a point-to-point connection with 2 autonomous systems. Autonomous System 64136 and Autonomous System 64136, 2 different ASNs. Each ASN has an addressing resource. We're doing the exercise with IPv6, so they have an addressing resource that is different. With these resources, we're going to create our ROA. It is telling us that the ASN 64135 is announcing a network, /34 in IPv6 and /34 to this autonomous system. So we have to create the ROAs from the autonomous system 64135, stating that this is our origin and that we're going to submit information from a /33 and a /34. If we receive this pool, which is a /32, and we disaggregate it and we create the prefix /23 and /34, we're going to state how we are conducting our traffic. And then we have ASN 64136 submitting information with a /34, and that will be the only ROA that will have to be created by that autonomous system. I don't know whether Nico will be able to show the system of Luckner. Let us take a look at how this validation takes place, how we create our ROA. We have the Luckner system, the Luckner system. That is how we manage our resources. Remember that the Luckner system Could you put up the presentation in Zoom to do the exercise, please? So from the Luckner system, we're going to be able to manage our resources. Remember, we have different users in the Luckner system. We have a user that is the administrator and a series of technical users. The idea is to access the Luckner system with our technical user, which will allow us to find in the panel on the left, in the services part, you will find a segment called RPKI. So from there, you will be able to see that there's a space stating create ROAs. That's where we're going to create the certificates, and you will note that there's something quite simple. This is information. Remember, these are 2 topics that we have to take into account. One, with what autonomous system we wish to publish the information, and secondly, how we're going to break this prefix down. If we are delivering /24, if we are breaking it down into /34, so we have to state this. In this example, we're going to do this with an autonomous system that we have assigned for Luckner, an IPv6 addressing that has been assigned. So here, we're going to put a name. In the name will allow us to identify that segment which we're using for peering purposes so that you can follow up each of the certificates. The connection, therefore, of Luckner to autonomous is 64134 that is being announced. So we're going to enter the origin autonomous system that is sending out the information. Then we're going to have a space stating the validity of that certificate. If we break that segment down and know that it won't be moved, we're not going to be breaking it down again, we can assign a relatively long duration, 2, 5, or 10 years. If we change this once again then we have to update the validation of that certificate that we're going to create. The certificate will expire depending on the timing validity period you entered. Then there is a space we're going to enter each ROA. Remember that I was telling you that we made the announcement through a /33 and a /34 prefix. What we are doing here is creating the ROA for the autonomous system that is publishing the 64135 that we had in the peering example. And it was announcing two segments. One was a segment /33 and the other was a /34. This shows the minimum and maximum of that prefix. So this will be disaggregated from 33 to a prefix 48 and from 34 to a 48 prefix. So once we create that, we won't have to enter any further information. We click Save, and we have created our ROA. We then enter the ROA section, which is under RPKI Services. There you will see the list of ROAs that were created. In this case, it shows the validity until what date. There you have /33 and /34 on the right. These are resources, and shows through which autonomous system this is being published. If we wish to edit or update the information, we click on Edit or Update, and then Update. When we create the ROAs, we'll see that in the status of the database. Let me remind you that the database of each regional internet registry where these digital certificates are stored, they will receive this information stating that Autonomous System 64135 created these two certificates. And these will be hosted in that database. Once these are saved in that database, the networks that are doing validation of origin will be consulting these validators. They will view this network as a valid network. If they receive information in their networks from this autonomous system, if they receive traffic from this autonomous system, in the VGP table, when we enable the RPKA part, we see a new attribute on that routing table. And that attribute will show whether this is a valid or invalid or not found certificate. We're going to look at this in the practice section of the tutorial. So once we see the results, then we'll be able to filter. So as you see, when we create these certificates, we are not touching the infrastructure. We won't have interruptions in the service because this only submits information to the database.
However, we need to be careful of how we create it, and we know that we are breaking down our information and how we are doing, how we are publishing that. So from there to draw information and create our digital certificates, you see that well, now we can go back to the presentation. There we are. So there you have the example for creating Autonomous System 64135, and there we created the certificates. Let me show you the software that we used for validation purposes. I don't know whether you remember when I showed you the topology of the validation part, that I said that we are going to have servers, validating caches. Those servers will have this validation software. We'll have to install some programs for them to come and request the information to this global repository of the internet registries where all the digital certifications are stored, and so for our validating cache, I'll show you what will be installed in the validation cache. The software available at present to install in those validation servers, we have the first validators available online was the one developed by RIPE NCC. That is one of the most popular validators with the infrastructures that are validating that origin. But we see that it hasn't been maintained since June 2021. Now we have other validators, the Go RTR and Go RPKI, that are developed by Cloudflare, and they are free of charge. You can install them in the validating cache. We have one that was developed by NLNUPS, that is Routinator 3000, and we have one of the validators that is most popular here in the region, that is the Fort validator that was developed jointly with NIC Mexico and LACNIC. And all of these validators do this job of requesting the global repositories and bring the digital certificates to our infrastructure. So then these validators send that information to our routers, and our routers in their tables will see all the routes that are valid, invalid, or not found. So this is a Fort validator. It's an open source validator, and in the presentation you have the links to see the overall information, how to install it. It's very easy, very user-friendly, and now you'll have access for the hands-on session. And in the practice you'll have, in the case of Fort, you'll have the instructions of how to install it, and you'll have access to a video that explains, a tutorial, how to install it. Well, so wrapping up this presentation, here you have some references. Let me tell you, well, in LACNIC, this is a tool that most of you are familiar with to manage your resources. In the case of Mexico and Brazil, it's different, but well, we each have our own administration system. Here we leave 3 tools, LACNIC tools with information on the RPKI tools. Here you have all the information about the resources. So this is very useful when you conduct diagnosis. InfoRedes is information on numeric resources, IP resources and autonomous systems, and it has systems that have to do with routing and connectivity, DNS. The Fort monitoring is part of the Fort project that Erika mentioned. The Fort project developed the validator, and in this website you can check the coverage of our OAs and anomalies in the routing information. If you enter there, you'll see the router announcements, those that are valid, those that do not meet the requirements of RPKI, those that don't meet RIR. For instance, in the RIR provides inconsistent information. Then you have RIPE risk, Michela Galante. If you have any doubts about this, you can get in touch with her. Here, Harry Canaletti is also provides you information about these. Well, we have some questions, and then we'll have a brief session for questions. Massimo will speak English, so those of you who need translation, please, you can go out and go for get your headphones. So let's see the Q&A part. Yes, and if there are any questions here in person, please, you can get close to a mic. We have 3 questions. 3 questions from the remote participants. Francisco Figueroa Cepeda says, I have a client that has his own autonomous system, but they don't have any assigned IPv6 segments, and they're requesting me to lend an IPv6, and can I create the ROA with this data? Well, here what he's telling us is that the client, the customer, doesn't have any IPv6 segments assigned, but they do have an autonomous system. In my understanding, this is Francisco's customer that is accessing services through that. So here, the segment that Francisco will deliver must be created by him, but he's publishing it through his autonomous system. So, in this case, Francisco is delivering the segment, and we must see whether the publication is being done through the client's autonomous system. That can be done, no problem. So that prefix will be created indicating that the origin autonomous system is that of the clients, even if the prefix was assigned by the ISP. If the publication is going to take place with the ISP's autonomous system, then the prefix that will be delivered to the client will have to indicate that it's being published by the autonomous system of origin, that in this case is that of the internet service provider. Yes, and with regard that, well, first of all, here it says whether he can lend him a segment. I assume that it's an internet provider that is delegating a block to a client. It's not lending or borrowing. That's not right. Now, however, there's a policy that is under debate in the public policy list that will be discussed, I think it's tomorrow, that has to do precisely with this, with the potential that when you have a delegated block, that the ROA may be created by the organization that has been delegated and not the superior provider. Now, if you receive a delegating block, it's the provider that has that. That would not be possible. The provider should do it. Now, there's a policy that's being discussed. So, since you asked this, please pay attention when that is discussed in the Public Policy Forum, and tomorrow you'll know what it's all about. Now, the next question by the public. Could you give your name and the company you represent? Can you hear me? Yes? Good morning, everyone. I'm Nicolas Cañar. I administer UNICEF Cauca Network, and my question is as follows. We have resources assigned by LACNIC, and we received the RPKI authorization of each of the announcements. Now, my question is, why do I also have to create an RPKI for my carrier's AS? So it's happened to me that if I don't create the RPKI for my carrier's AS, I have authentication problems with that RPKI. I don't have to authenticate the origin of my AS, but also of each of the carriers. I don't know whether that makes any sense. And we have checked it, and we announced it from our AS. Now, if you go to a looking glass, you see that it's announced from our own AS. Now, if I don't create the announcement from the RPK, it puts a looking glass wheel in my authentication. Well, that's a strange thing. That shouldn't be the case. If you are announcing, the BGP announcements are coming out with the autonomous system of origin from your autonomous system, the ROA that you have to create is with your autonomous system. Now, it's possible to have announcements created or originated with an autonomous system of your carrier. And in that case, that announcement, unless if you don't create it, it will be invalidated. But we should see how you're doing the announcements. This is sort of what Erika said at the beginning. How are you publishing the announcements? And if the ROAs that you have created are consistent with the lengths, the disaggregation, and the autonomous systems, for the monitoring and the RPKI tools that I mentioned are precisely for that, and Massimo will address that. So the ROAs that you create necessarily have to be authenticated with my AS of origin and none other? Yes, none other. That's right. Well, anyway, among the tools that Guillermo showed you, you have this in Lacknick tools that will also help you. You enter this, you put your autonomous system, if you have one, or a prefix, a specific prefix that you have received, and then it will give you the disaggregation and how you're making the announcements, and there you'll see how you're disaggregating the routes and with what autonomous system you are publishing it with. But indeed, it'll have to be the autonomous system with which you are originated the information traffic. That's why it's called validation of origin of the autonomous system that is originating and sending the information. Now, our last question from the remote participants. For the rest of the participants, we are going to respond through the Q&A. Elliot points out, Elias Mayorga says that, what would it be like if it were the other way around? That is, creating a digital certificate with a client that doesn't have an autonomous system, but this resource is being delivered by the service provider. And the client doesn't have his own autonomous system. In this case, it's a service provider that is responsible for creating these digital certificates, listing all the addressing pools and create the certificate with the service provider system, because it's with that they are announcing that route. So let's continue with the chat questions, and then Massimo will be invited. Yes, so now we'll give the floor to Massimo. Remember that he will speak English. Now you can ask questions in English, in Spanish, and there's simultaneous translation, both in Zoom and in the room. If you need any translation, please go and get your headsets. Massimo, go ahead. Thank you.
Hello? Okay. So, buenos días a todos. Yo soy Massimo Candela. Estoy muy contento.
I'm Massimo Candela, and I'm very, very happy to be here after 2 years of pandemic. I'm in charge of the last part of the tutorial. It's going to be in English. However, if you have any questions, please do not hesitate. Don't be shy. And you can speak Spanish to me. And I'm going to answer in English or Spanish or Italian.
So I'm going to start sharing and the entire screen. It's for me easier to present in English. I'm sorry for that. So, as I said, my name is Massimo Candela, and I work for a company called NTT. NTT is a large company that does a lot of things, among which we are a tier 1 provider, and I work on the automation and monitoring. And today the topic is about automation and monitoring of RPKI, in particular monitoring of RPKI, Okay, so, and I would like to start saying why it's important to monitor. Well, first of all, if you operate on BGP, and I think monitoring is a fundamental activity. When I talk about BGP monitoring, a lot of people think about hijack detection, but that is only 1%. The rest is operators making errors. We do errors, you do errors, everybody does error. What you want to do is actually to monitor, because you want to be aware of what you are doing, what your autonomous system is doing, and if you are, for example, announcing a prefix that you were not supposed to announce, you want to be notified immediately. Or you provide you do a new network configuration, and then you want to immediately be informed if you are losing visibility, for example. And then there is also RPKI, this relatively new thing that actually it's a technical solution that goes in parallel with BGP. They are supposed to be working independently, but at the same time, you will need effort to keep them in sync. And usually, people think that RPKI is only like implementing RPKI means like doing route origin validation and creating ROAS. But the reality is that once you will have it in your network, it will impact your daily operation. It's a thing that you have to keep in mind every time you do, for example, BGP operation. So you need tools to monitor and to ease your operation. The tool that we will use is called BGP Alerter. Maybe you heard of it, maybe not. And I thought that it was a good idea to create this software and release it public, open for everybody to use, because an NTT, it's my company, was really supportive in that, actually. And because we believe that there are different levels of expertise, and not everybody has for example, the energy or the software engineers to develop solutions ad hoc. So having some easy to use and open tools will help you, will help in general the global internet to improve the stability of the entire global internet. So, but what I'm talking about is mostly, essentially, that you need tool, for example, to check that you are not doing RPKI invalid announcement. This is a quick overview of a quick and dirty analysis that I did. What you see here is the year 2021. I will speak with more details tomorrow about this. In 2021, basically, this is only RPKI invalid announcements. That they were invalid for max length reason. And you will see that 40% of those, they, on average in 2021, get resolved in 1 day, while the rest, so 60%, they actually take more than 1 day to get resolved. And we have at least around 15% of these RPKI invalid with max length. They actually they take more than a month before they get resolved. And we don't know how much, because I checked only with a time window of a month. Anyway, this analysis, there are a lot of things that you should take into account while you analyze these numbers, but this is just to give you a quick overview that shows you that you need to monitor. Again, this is something I will show tomorrow. This is what we managed to achieve with monitoring and automation. We reduced by 87% our error rate, so our RPKI invalid announcements. And today the tutorial is will help you to achieve similar results. And the first thing is we will use this tool, which is BGP Alerter. And you can go, you can download the slides and go on this URL here, which is the source code, or you can just go on Google or whatever search engine you want, and you just look for BGP Alerter. It works in real time. You get notified immediately if something is going on, and it is easy to use, includes auto configuration, and there is no data collection that you need. It's an application that you run, and we will see it today. So it does use open data sets. That's why you don't need to collect your data. In particular, the BGP data is coming from RIPE RIS, the RIS Live project, and that it's a network of route collectors distributed in the world that you peer with them if you want. There are more than 600 peers, and basically they act like if they are normal BGP router, but in reality what they do, they store this BGP data so that everybody can use it. It's an amazing project by RIPE-NCC. There is one route collector hosted by Luckner in Montevideo. It's the number 24. If you want to peer and also contribute to this amazing project, you can go to this URL, or even better, there is in the audience, I see it there, but you probably all know her. It's Michela Galante from RIPE-NCC. If she's not busy dancing, she's going to help you. And this is a list that it's getting annoying to do during the presentation because it's getting longer by each presentation. This is the list of things that you will get notified when you will have this software running. So for example, if your prefixes will lose visibility, you will get notified. If your prefix is hijacked, or if you are announcing RPKI invalid, or if you are announcing prefixes not covered yet by ROA. And this is, you can disable if you have a partial RPKI implementation. If you are announcing something that was never announced before, is it good? It was an error, you can check. If your ROAs are expiring, because yes, ROA do expire, and not only your ROAs, but also the entire certificate in the chain. And a shout out to Job Snyder with RPKI client for supporting all the data needed for this monitoring. You get notified also if ROAs covering your prefixes are no longer available, or when there is a trust anchor malfunction. This is also really interesting because trust anchors may fail and you may spend time trying to debug something that is not related to you. Or ROA involving any of your prefixes were deleted, added, or changed anyway. So basically you can share in a channel something, and if your colleague changes a ROA, you get notified, and so that you are all in sync. Also, you get notified if any of your upstream and downstream autonomous system, I don't know, there is a new one that appears in a BGP path, which can be normal or can be a symptom of a specific type of leaks or a hijack with path mangling and stuff like this. Or you can get also notified about whatever condition you want to put on or on path. Okay, so all of this happens automatically because there is auto configuration. This is an example of what you will see in, for example, this is our Slack channel. You can connect it to Slack, you can send it by email, you can do whatever you want. This is an example of the alerts in RPKI. If you look at the second one in particular, you will see that is the diff I was telling you when a ROA is edited by somebody of your staff. Now, let's start with it's going to be really quick because it's everything done automatically. So if you have your laptop, please open your laptop, download the application. The application name is BGP Alerter. You go on the Git repository. Actually, I'm going to do it live. So here, if you go here, the main page, there is here release 129.0, which is the last one. And you go here, you have it already compiled for all your platform. I will download it for Mac OS because this is Mac OS. I created a directory on my desktop for this demo where, since there were like network issues, I already downloaded it, okay? But you can just do, you can just copy the URL with this, copy link address, you go here and you will get URL, right? So please do, and I give you some minutes if you are planning to do that. Yeah. And you can go back on the presentation. So how many of you did download it? Raise your hands. I need at least 5 hands before I can go ahead. This is never going to finish then. Anyway, okay. I see how this is going. Please do. Are you trying? Is anybody trying? At least trying? You can blame the network. You can say that the network is slow and stuff. Okay. So I'm going to imagine that you all did it. And go ahead. So I'm here in the, I hope you can see. Is it big enough? Okay, I think it's big enough. So as you can see, I have just the application, the BGP Alerter application. I'm going to show you how simple it is to enable your monitoring. And seriously, you should monitor. If you operate on the internet, you should monitor. And this is just make it executable. There is also for Windows if you want, which is and now I just run it. And I will show you that the tool will automatically ask me, okay, this is the first time that the tool is running. Would you like BGP Alerter to auto-configure it? So we say yes. Yes. Okay. So now he's going to ask which autonomous system we want to monitor. So I'm going to use the RIPE NCC autonomous system 3333 as an example. You can put your own autonomous system if you are a big network like 2914 NTT. It's going to take a good amount of minutes. So maybe you can try with something small to be fast at the beginning. It's going to ask you, do you want to be notified when your autonomous system is announcing a new prefix, which could be a symptom that you may have done a typo, for example. We never saw you before announcing this. The first time, do you want to get an alert when that happens? Yes. Do you want to get notified when a new upstream autonomous system appears? Yes. The same for a downstream AS. Yes. The auto configuration starts. He's going to detect all the prefixes that your autonomous system is announcing. He's going to compare those with RPKI. He's going to validate them. If you don't have RPKI, he's going to work anyway, but he's going to ask you to double check if the entire list is correct, because if you don't have RPKI and you run the auto configuration, maybe during an hijack, he's going to see that as the current status. He detected all the upstream and downstreams, and it says that it's done. Now you will see that, there we go.
Ahora verán, ahí lo tenemos. Empezó el monitoreo, ustedes oficialmente están monitoreando. En este caso yo estoy monitoreando oficialmente el PCC. Aquí volvemos a la presentación. La pregunta es, ¿terminaron? ¿Sí? ¿Cuántos de ustedes? No todos juntos, no contesten todos juntos. Bueno, ahora, revisando la lista de los prefijos, la lista de prefijos es esta. Bien, la lista de prefijos es esencialmente el lugar donde está toda la configuración, donde se almacena toda la configuración de los prejuicios, de los prefijos que están anunciando. Como pueden ver, hay un prefijo, una descripción. Puedo ampliarlo un poco más. Y dice, no se brinda descripción. Esto es por defecto. Ustedes aquí pueden dar una descripción. Por ejemplo, pueden decir no que encale o algo así. De manera que cuando ustedes reciben una alerta, les va a contar después del prefijo, les va a decir, bueno, usted está recibiendo un secuestro de este prefijo, cuál es el prefijo encale, y ustedes van a saber inmediatamente.
Like, for example, which group of users is going to be notified. In this case, the knock is by default. You don't need to configure that, but there are more advanced configurations that you can do. If you want to ignore that prefix, imagine that there is a prefix that you use for research, and so you do all crazy things. You don't want to monitor that, you can set ignore true. Okay. Then we review the prefix list. Also, as I said, you can receive this by email, these alerts, or you can send it to Slack, WebEx, Mattermost, all sort of things, all kind of apps possible. This is an example of email that you would receive. For example, this is a case of basic hijack, and it says that one prefix is announced by another autonomous system instead. And
¿Usan Slack acá?
Do you use Slack? Could you raise your hands if you use Slack? Just a few, because it's very interesting what Maximo is saying. It's very interesting. If you want to send the monitoring results to a Slack channel, in Slack you may have a separate Slack, and you receive the alerts and everything that Massimo is saying. You can reach it in a channel.
Almost real time, and we also use it at NTT. We have it on. I have it on my phone, so when something happens, you immediately receive the notification. And now the next step that I will do is I will show you how easy it is to do that integration. We will see on fly. This time we open a file called config.yaml. Come on. Sorry. Keep this. Okay. There is something going on. Thank you. So you see here, it's the monitors. Each feature is implemented in a different thing. So if you don't want, like for example, this, you can comment in or comment out. This, we enable it, we disable it. And the same is for the wrappers. By default, you will receive all the alerts in files, like log files. This is because I configure BGP Alerter in a way that you run it, like I showed you before, and it just works. But if you want to do something more advanced, like send it by email, this is what you want to do. You basically take this part, you remove the comment, now it's active. You put the sender email or your SMTP configuration, and you are good to go. But there is also, now let's put it back. But there is also, like, I don't know, Slack and Kafka, syslog, Alerta, which is a dashboard, WebEx, whatever you want. So that's to make you understand how it works. Now, one of the most important things that you should do when you have a monitoring system in place is to monitor the monitoring system. I know that sounds like a never-ending, but the monitoring system, in this case, BGP Alerter, is pretty stable. We use it in production for years now, and many companies use it, many big companies, other tier 1 CDNs and content providers. But still, you want to be aware when something is not working, and so when you are not protected by the monitoring. What you should do is to enable uptime monitoring. So if you go on this file, there is this process monitors, and there is this first thing which is called uptime API, there is also these other health checks where it says sends a heartbeat to a URL that you provide. But I prefer usually this, which is super easy to do. So I basically remove the comments. And what I do now is I go back here and I restart BGP Alerter with just this removing from the comment that by default is gonna open an API on localhost port 8011. Okay, now it is monitoring, and if I go here, port 8011, I do, okay, maybe it didn't work. Good. Okay, let me just start. Okay, we have already running news. This is when you do live things. Oh, okay. It's easier to do this. I have it on the other account running. Okay, the monitoring started. Okay. So, and you can see that in this moment there is a warning going on. Okay, now it went away. So the system is up and running, connected to all the repositories. The RPKI data is downloaded, it's fresh, it's not stale. Everything is working. So you can use this URL periodically and check it to see if everything is running. Now the tutorial is almost finished. There is last one part, which is RPKI. So as I said, this monitors both BGP and RPKI, and it is already running. It is already monitoring RPKI. But what it is using is, where it is, some public repositories. So it connects, in this case, to rpkiclient.org, which is hosted by a famous CDN, and downloads a VRP file, so basically downloads their RPKI resolution, but there is also a RIPE, there is also an NTT one, you can change the provider, there is an entire list. And this allows you to just running without having your own RPKI validator. But if you are doing RPKI validation, which you should, then it's better if you provide your own file. So your own VRP file, you provide it in input in a way that you are not only monitoring, you're also monitoring the same RPKI validation process that you are doing, if the file is correct or not. And also you are not trusting anybody else in doing the RPKI validation, which is an important principle of properly implementing RPKI. To do that, you just do file, and you provide where the file is. So for this experiment, I'm using the NTT one. So what I will do is I will kill this. I will download it. And it's going to download a file called export.json, which is just a classic VRP file, which is the output of, can be CSV or can be JSON. It's the output of an RPKI validation process. And so I can do ls, so you can see that now these are all the files that BGP Alerter automatically created. We downloaded only this. He created, well, the file with the PID, the config auto-configuration, the prefixes that we saw before, the directory logs with all the alerts and all the logs of the application. But now I also downloaded this export.json, okay? Then when I go here, VRP file, I write JSON. This, it doesn't matter. And the other options, they don't really matter. The only option that matters is the VRP file thing. If you have a process that your RPKI validation every 15 minutes updates your export.json, you do not have to restart BGP Alerter. BGP Alerter will watch export.json and will update the RPKI data every time that file is changed. So now I'm going to run it again. Okay, monitoring. Now if I go in the status API, this was saying that it was using provider RPKI client. Now I'm going to refresh. When I'm going to refresh, it's actually using the same. I did the same error of before. I didn't save the file. There we go. Now it says it's external. Zoom this. Oh. The shell? Which is? No, this is, you mean this? Oh, it's, okay, this is the part that I'm telling. This, the VRP file part, the export.json file. So this is where we put where our file is. So VRP file and the file export.json, every time that export.json will be updated by your Fort validator or RPKI client validator or whatever you're using, BGP Alerter will automatically refresh the raw definition and your monitor will continue. And after I did this change, I'm going back here and you can see that now it's using provider external, not anymore RPKI client. Before we were using RPKI client, which was a remote, and external means is essentially a file external to the application that is loaded every time. And basically in this way, you can put your file and use your own validation. So yeah, this is what we did. And basically my tutorial is finished. I want to, if you have questions, please ask. And you can also contact me, or if you are interested in BGP and RPKI topic or automation and network measurements, you can also follow me on Twitter. Sometimes I provide updates about this topic. Thank you very much for your attention.
Bueno, gracias, Máximo.
Thank you, Massimo. I don't know whether there are any questions. We don't have any in the Q&A panel. I don't see anybody in the room asking any questions, but Massimo is going to be around. He's going to stay all week. And you have a presentation tomorrow, right? At 12:30, he has a presentation, but you can find him around here.
And like Massimo said, you can speak to him in Spanish. So he was right on time. Thank you very much. Now, the idea we have now is that Nicolas, if you are around, please send a sign, a signal. Nico is going to show the lab we're going to do this afternoon. Nico, hi, are you there? Do you have the Zoom audio? Hello, can you hear me? Yes, great. So Nico, you have the floor now. You can go on with the presentation. Show the lab And please stay on because we're going to organize a Kahoot and there are some prizes. So let me explain the lab we're going to have this afternoon. I would like to clarify something. Can you still hear me, Guillermo? Yes, we can see nothing on the screen. You're not sharing anything. No, I'm not sharing anything. So I'm going to send to all the participants. I'm going to paste some of the links that you're going to need. The first thing is a link that will allow you to reserve an instance for the laboratory. So if the network allows this afternoon, those of you who wish can click on that link, which I sent to everyone in the chat in the Zoom, and that link includes a Google form. You just have to enter your name and your email address. It's important to enter your name, and then the lab system will reserve a lab instance for you. Afterwards, you just have to see the number of the group that was assigned to you. So with that aim, after you have filled in your form, you will access the next link that I'm going to include here. And then you will see a form containing all the names of the people who registered for the lab, and next to the name you have the group number. That's a group number that you have to take note of because that will be your identification in the lab, and that's the instance that will be assigned to you during the lab. And finally, for those of you who wish to participate and who have completed those 2 stages, you'll get another link that you can download. Please download this file. It is a text file separated by commas containing all the passwords of the lab instances. Use only the credentials for that instance that has been assigned to you. So, for example, Nicolas Antoniello, for example, is group number 1. So I'm going to go to instance number 1, and from all the passwords, there are only 2 passwords that I'm going to use. Nico, yes, Guillermo. We have an issue here, and the people who are in person here are not all connected to Zoom. So what we're going to do is to include this in the website containing the description of the tutorial. Anyway, it won't be so easy, but we can include this in the page where the tutorial is described. So, well, the important thing is that you can put it in the website of the tutorial, is that they will find a link that Nico says is a form where you fill in your information for the lab and you will be assigned a group number. And then you will have a link and you will go to the lab and follow everything step by step, and you will be able to see the topology, etc., etc. So let us do this rapidly so that you can see it. So can you view my screen? Can you see my screen? Yes, Nico. So the first link, in the link that going to enter in the agenda of the link in this tutorial section is a form. There you fill in your name and your surname, your last name, and optionally your email address. You click on submit, and then this will reserve an instance in the laboratory. Then you will have a second link, which you will find in the website of the tutorial, which is the one I'm going to paste over here. So you enter the second link, And then you'll receive this form containing the list and the group number. For example, I was assigned to group number 1, Guillermo to group number 3, Erica to group number 3, and there are some other people who have reserved space in one of the labs. So I'm going to use group number 1, Guillermo 2, Erica 3, Santiago 4, and so on. And then there's a third link, which are the passwords to access the laboratory. You can download that. You click on the link, and it will take you to this file, which is CSV file. You click here on download, and you can download it locally in your machine. Those who have been assigned to group number 10 of the laboratory will use this password here, which is a password to access your router. And if you scroll down, this is group number 10, and this is a password for accessing your client. In the laboratory, each of you will have 2 devices, a client, which will be a Linux terminal, and a router. And with that client and with that router, we're going to practice the laboratory. So once again, access the form, enter your name, then access the form to see what group you're in, and then a third file containing the password corresponding to your group. And then the password for the router. So that is all. And the rest we will be seeing in the second part during the lab. Guillermo, Erica, during the laboratory we'll be sharing this, and we'll be following this step by step. We'll be circulating around the room and assisting you. As people join us, you'll be able to participate in the lab. So we'll give you some time so that you can connect and set this up. Those of you who cannot access it, or don't have your laptop, or cannot have access to the URLs, well, you'll be able to follow the explanation of the lab as we go along. Yes, one additional comment, Erica. Given the conditions of the Wi-Fi network, if this afternoon the same thing happens as happened this morning, those who are following us remotely will be able to access the lab because the lab is outside in the cloud, but those who are participating in person might not access the lab. Nevertheless, like Erica was saying, we're going to be going step by step. We'll be following the different instances of the lab, and the remaining of today, the lab will be running. So once the lab is over, if you wish to access your group and practice when connection is better, then you will be able to do so. So if there are no further clarifications, Guillermo, we can go over to the Kahoot. All right, let's go over to the Kahoot. The URLs will be included in the tutorial website, but we haven't done so yet. Can you see the Kahoot? So do you know how this works? You have to enter that PIN. You enter www.kahoot.it, enter the PIN for this game, 156272. You have to create a name, a fantasy name. Remember that the minimum rules of behavior apply to here. So no hostile names or nothing of the kind. So let us wait until we have sufficient players. So let's wait. We have about 27 participants. Let me remind you that you have to access the site at the top of the page, www.kahoot.it, and the PIN you have there. We have 45 participants. What is the prize, Guillermo? Would you like to tell us? So people continue joining us. In this first stage, we're going to ask some questions regarding the theoretical presentations, and at the end of the afternoon session, we'll have another Kahoot with questions focused on the lab and the testing that we'll be conducting after lunch. "78 and counting."
Para todos los que estamos remotos.
Bueno, vamos a dar un último minuto para que terminen.
Let's wait one more minute so we can start the game.
Listo. Nico, iniciamos con los que están
Bueno,
dentro.
ahí iniciamos a la 1.
So let us start. 1, 2, and 3.
Hay algunos que se apuraron ahí. Bueno, vamos,
106.
The questions are quite tricky. What is an IXP? IP address registry, a site where you can do broadband clearing, a facility that allows different AS to get connected, a site where ISPs buy internet transit. Correct answer is a facility that allows the different ASs to interconnect with one another. So what are the positions? Ruth, CMT, top of the list. None of the usual suspects has managed. Second question. Some of the advantages of having a route server are to apply health measures to IXP routing, to resolve DNS, recursive of the DNS, to protect access to the internet of the users, to resolve authoritative resolution of the root zone of the DNS. Right answer is to apply health measures to the IXP routing, as explained by Guillermo. That was the main purpose of that route server.
De medidas. Bueno, ahí cambia y va Ramiro 20255 de primer puesto, Enzo Picero segundo puesto y Ruth CMT del tercer puesto. Dale, Nico.
Leo la tercera. RPKI y los IRR sirven para poder verificar la lista de invitados a la CNI 37, verificar la información de BGP contra una base de datos, poder verificar la información de juiz o poder verificar la información de contactos. Muy bien, la respuesta correcta es RPKI y IRR sirven para, de alguna manera, verificar la información de BGP contra una base de datos, en el caso de RPKI, autenticada. Bueno, el marcador se mantiene ahí para algunas posiciones. Ramiro primero, Ruth CMT segunda y Enzo Picero está en tercer puesto. Y hay algunos que vienen ahí subiendo. Erika,
Siguiente.
te la dejo a ti.
El peering privado puede ser bueno para, no sirve para nada, uso de IPs privadas y NAT, conectarse a un IXP, conectar un peer con mucho tráfico. 5 segundos para cerrar el tiempo de respuesta. Perfecto. Efectivamente, la respuesta correcta es conectar un peer con mucho tráfico, como lo vimos en la parte inicial del tutorial. Vamos a ver cómo están los resultados de nuestro ranking. Cambió bastante, aunque sigue Ramiro 20255 en la parte de primeras.
Y ahora la última pregunta. Tránsito. ¿Qué es tránsito? Es un sitio de interconexión de sistemas autónomos, es circulación por Internet, es un servicio de conectividad a Internet con costo por megabit por segundo o no tengo la más mínima idea.
Bueno, ¿quién respondió? No tengo la más mínima idea. ¿Qué pasa?
Está bien, hay que ser honestos. Entonces, me parece que no estaban atentos a los comentarios de Guillermo ahí en la primera parte. No, la respuesta correcta entonces es, bueno, es un servicio de conectividad a Internet con costo por megabit por segundo por lo general, ¿sí? De todas las respuestas que están ahí, la correcta es esa. Y vamos a ver las posiciones finales. El podio, en tercer lugar, Antares. En segundo lugar, Julián L. Y en primer lugar, Ramiro 20255, que eso tiene toda la pinta de ser un sistema autónomo o algo parecido, ¿no? Bueno, después, quienes tienen estos usuarios, capturen la pantalla y hágansela llegar ahí al staff de LACNIC y a Guillermo para recibir su premio. Porque
si hay
es la
alguno de las personas que están en este ranking presencialmente, puede pasar a la parte de adelante para recibir su premio de una vez. Y si no, lo hacen como está indicando Nico para nuestros participantes remotos.
Bueno, hola. Entonces, bueno, con esto termina esta primera parte de la mañana. Ya les dijo Nico, pasen la información a los que son remotos. Bueno, ahí tenemos le damos un aplauso a uno de los que se llevó un premio. Ahora le doy la para que dé el cierre a esta parte de la mañana y nos vemos más tarde.
Hola. Muchas gracias.
Hello, thank you, Guillermo and Erika, Massimo, Nicolás. Thank you for this first part of the tutorial. Thank you, all of you, for having participated. Now we'll have about an hour break. And before we start this lunch break, I'll invite you to get engaged in the media, to share your experience using hashtag 37 or by tagging us. Remember that we are going to have shuffles with a daily winner. So please share your pictures, and we also have the thematic event that you'll be able to share with the hashtag LACNIC37. Now we'll have the lunch break, and we'll resume at 2 p.m. local 19 UTC for those of you remote. And remember that we'll go to we'll go outside for lunch. We'll resume at 2. At the food court.